Okay, hello everyone. Welcome to the channel. We're doing paper 1 of grade 10 mathematics. It's a 2020 paper. So check out this website, guys. It has a lot of cool papers that you can use to practice. Remember, I hope I'm audible enough. With maths, you need to practice as many questions as possible. You can't do one and think that you understand. At least do 5 or 10 of the same thing. Do many questions on one topic so that you're comfortable with it. You avoid making silly mistakes like sign, forgetting to put the sign, or being stuck. The more you practice, it becomes easier to remember the principles that you're doing. So let's do this paper as soon as possible. I've been postponing to do this, so let's just get down with it. Yeah? So, okay. They give us this question. They say, for which of the values of x is the expression, this expression, they give us the value of x, all of this, 11 minus 5, 0, and 15. What would make this expression to be rational? Which value will make this expression, for which values of x would make this expression rational, would make it non-real, would make it undefined? So I'm just going to work with it here. Let me start with this one. For an expression to be undefined, the denominator must be 0. So if I have anything, x represents any number over 0, it will make our expression undefined. We can never have anything to over 0. So let me put whatever number over that, you get undefined, math error, to tell you that it's so anything that would make the denominator 0 will make the expression undefined. So what here, if I put it in the value of x, would make this expression to be 0. Yes, 11, right? So if I put 11 minus 11, I'm going to have 9 over 0. Can you see the denominator is over 0? This means that x equals to 11 would make the expression to be 0. I hope you get it there. And then non-real, you shouldn't forget this, especially for next year. Non-real, what value would make this value to be non-real? If we have a negative number inside the square root. So any number, I'm just going to write it like that. If we have a negative number inside the square root, that would make the expression to be non-real. When you get to varsity, you're gonna talk about imaginary numbers, where we can actually work with a number with a negative number inside the square root, but we call them imaginary numbers. They are not real. So can you see, it doesn't work. So anything that would make this expression to be negative. So if I subtract by a number bigger than 11, would make this whole thing negative. So if I put 5 is a negative, so it's going to be 11 plus 5, it will give me 16. So nope. If I put 0, it will give me 9 over 11. So nope. If I put 15, let's try. 9 over 11 minus 15. So obviously this will give you a negative 4. Let me just show you. 11 minus 15. Can you see you have a negative number there? So inside the square root, we have a negative number. We have a negative inside the square root. So negative over that. Can you see? So this is non-real. So they are not asking you to solve the question. They want to know the value of x that makes the expression non-real. So your answer would be x if x is 15, then it's non-real. I hope you are getting it. So a rational number, can I write a rational number here? What is a rational number? A rational number, it's any number that can be written as a over b, where b is not 0. So meaning any number that can be written as a fraction, any fraction. All fractions are rational numbers. Also recurring and finite decimals. But I'm just going to focus on this one. If I can get something like this, so I can just see, if I put minus 5, look, a equals to square root of 9 over 11 minus 5. If I put minus 5 inside there, I'm going to get, I hope you can hear me, 11, negative and negative is going to be a plus. So 11 plus 5 will give you 16. So according to the square root, I can break down the square root. And then I get 3 over 4. Can you see? You can just put the whole thing there, 9 over 16. You get 3 over 4, which is a finite decimal. Can you see? Or it's a fraction. So we call it a rational number. So what would make this expression to be rational? X equals to minus 5. I hope you can hear me. I hope I'm not too loud, but you can hear me. All right, let's simplify this one. So I'm going to work on the sheet now. Okay. Question 2 says simplify. So we're going to apply for 5 marks. 5 marks for how many minutes? For 5 minutes. So I'm going to factorize each. Okay, let's work here. I hope everyone can see. Now I'm going to copy it down here. The question says simplify, but I'm going to use factorization. It's a negative 12 there. Times x squared minus 16 over x squared minus 2x squared. Yeah. I remember I did this somewhere. Okay, let's just keep it the way it is. But here, it was supposed to be. Can I just do it the way it was supposed to be? Let's remove the x squared there and see where we end. Okay, sure. So the question said simplify, but I'm going to use what? Factorization to simplify. Can I write here? Can you see what I'm writing here? We have how many rules of factorization? I said 5. Yes. Number 1, look for a common factor. You know, when you do your factorization, factorize. Let me not, yeah. Dots. Difference of 2 squares. If you don't find a common factor, you check. Is it a difference of 2 squares? The number must be a perfect square. Meaning you have to, you should be able to find the square root of that number for it to be a difference of 2 squares. If it's not a difference of 2 squares, it's a trinomial. How do we recognize the trinomial? When they are 3 terms mostly. And then number 4, we call it grouping of terms. If we have like 4 terms, we can group them and then factorize. And lastly, it's a sum or difference of cubes. So also this one, it will be 2 terms, but they will be cubes, like 3. Difference of squares is like a square, like 2, 4, 6. Cubes is 3, 6, 9, blah, 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 blah. I hope you can get it. So let me write here which rule I believe I'm gonna apply. Here I'm gonna use this pen, trinomial. Can you all see why am I using a trinomial? Because I have 3 terms. Gosh, this pen's here. I'm gonna apply dots. Can you all see? Because of it's a difference of 2 squares. 16 is a perfect square. X squared is also a perfect square. This one I'm just gonna put bracket. I can't do anything to this one. This one I'm gonna find a common factor. I'm gonna take out a common factor. Here also, remember here it's a negative. I'm gonna take out a common factor because I don't see anything there. So if I factorize, can I just revise a bit on finding a trinomial? Can I do it here? I want to do it here. Yes. If they give you something like this, remember we said we look at the first term and the last term to give us the middle term. So we're gonna do a cross multiplication there. Here I'm gonna write the product of x squared in this column here. In this two column, I'm gonna write the product of x squared. X squared is made by what? It's made by x times x. This is made by x times x. And then it's 6. I'm gonna write the product of 6 there. That would give me, here there's nothing, so we know there's an invincible one, coefficient of 1. What are the factors of 6? That when I minus them, when I subtract them, they're gonna give me 1. 6 is made by 6 times 1 and 3 times 1. Which of these two, if I subtract, would give me 1? Obviously, it's this 2. Are we all clear? If it was adding, okay, something else different, but I hope you get what I'm trying to say here. You look for the factors of this, that if you subtract, how do you know that we are subtracting? We look at the term, this sign here. This sign tells us that we are subtraction. If it was a plus, we're gonna add. Now it's a minus, we are subtracting. If I minus this one from this one, I'm gonna get a 1. Can you all see it? So my factors will be 3 and 2. Can you see that you have a bracket already? So okay, can I just finish it off here? So meaning I've got, okay, you can test it, cross multiply 3x, 2x. I'm subtracting 3 minus 2, it's 1x. Can you see, which is the middle term? So I'm gonna say 3x, x2. Then I need to decide on the signs. If this is a minus, it tells me that the signs inside the bracket are different. I hope you notice that. If it's a plus here, the signs are the same. If it's a minus, the signs are different. The signs are different. Okay? So, okay, so if they're different, the sign in the middle term will go to the bigger number. Between 3 and 2, which number is bigger? 3 is bigger, so I'm gonna have a plus there and a minus there because the signs must differ. So going back to our question there, here I'm gonna have x plus 3 and x minus 2. Yes, let's go on. Here I'm gonna take out a common factor. 3 goes out. 12 is divisible by 3 also, so I'm gonna take out 3 here. I'm left with 4. I'm going to take an x and an x. So 3x goes out. I'm left with 1x there. Minus, if I take out 3 from 12, I'm left with 4. Yeah, I hope I am right. Times difference of 2 squares there. 2 brackets. One is a plus, one is a minus. The square root of x squared is xx. The square root of 16 is 4. I hope that one, everyone gets it right. So if it's 5 marks, they're gonna mark like that for each. And the bottom, I remove the square here. I strongly believe there is a typo there. There is a mistake. I don't know. So let's go on. Let's do it. So here I'm gonna take out what? I'm going to take out this x. So x goes out, x goes out. If there are 2 x's there, if I take out 1x, I'm left with 1x minus, I'm left with 2 there. Can you all see? Plus 1 over x plus 4. This one you can't really do much. And then we are simplifying, remember. So we start the cancelling process. Numerator by denominator, you identify the ones that are the same. So x minus 4 numerator cancels with x minus 4 denominator. X plus 4 numerator cancels with x plus 4 denominator. X minus 2 denominator cancels with x minus 2 numerator. I hope you understanding. Then we're going to write whatever is left on top. So x plus 3 times 1 becomes what? X plus 3. Yeah, boy. X plus 3. And then at the bottom, I'm left with 3x times x. So what's the answer? 3x squared. Something like that. So it's fine. Even if you do it with that square, you shouldn't worry. Cancel the one that are cancelable and leave out the rest. Okay, let's go on. Let's try to save time. I shouldn't talk a lot. So we do this one, it's exponents. So, okay, should I do it here? I'm gonna do it here. I'm gonna do it here. 12. Also this one. We're dealing with exponent. So I don't think this A is supposed to be there. This A, it's an exponent. So I'm gonna put it there. But do not worry because of, as long as you know the principles, you can do your thing there. You don't have to worry. So I'm gonna write our steps there. Okay, so let me write here first. Exponents. How many laws? I believe there are how many laws? 4. There are 3. There are 3 laws of exponents, and there are 2 properties. So law number 1 says when multiplying powers of the same base, we add the exponents. That's law number 1 of exponents. Law number 2 says when dividing powers of the same base, we subtract the exponents. Law number 3 says when we have a power raised to a power, we multiply the exponents. You need to know this. Only 3 that you need to memorize. We're adding, we're subtracting, we're multiplying. When there's multiplying powers of the same base, we add. Dividing powers of the same base, we subtract. And once you see a bracket, you multiply. And the 2 properties that we should know is that anything raised to an exponent 0, it's 1. So anything to the exponent raised to 0, it's 1. That's number 1 property. Number 2 property is that a negative exponent can be written as a fraction. This negative means 1 over. The exponent goes underneath. It doesn't go on top, underneath. So for example, if you are given 2 exponent 3, you're going to have 1 over 2 exponent 3. So that negative becomes this. You can move from there to there or there to there. So once you see a negative exponent, you can write it as a fraction. I hope you get that's all about it there. So for this, I'm going to write the steps here. The first step, step 1, you change all the numbers to be prime base. Prime base. So 6 is not a prime number. It's not a prime base, so I'm going to make it a prime base. How do you do it? You press 6, equal sign, shift, fact. Then it gives me the prime numbers or the prime factors of 6, which is 2 and 3. So in the place of 6, I'm going to write 2 times 3, open bracket, 2 minus a. I still write that outside. Can you see? Can you see? Yo, what am I doing now? Okay, 12 is made by, how do I write 12? 12 equals sign, shift, fact. 2 squared times 3 becomes our prime base. So I'm going to write 2 squared times 3 exponent a. Okay, at the bottom, 2 is a prime number, so we don't have to do anything to that one. Okay, that's fair enough. Step 2, we're going to apply law 3. Law 3 says when you see a bracket, you need to multiply. So I'm going to multiply everything there with the exponent outside. So here I'm going to have, here remember it's 1. 1 times 2, it's 2. 1 times minus a, it's minus a. Dot or times, whatever, it does not matter. 2 times a becomes 2a. 1 times a becomes 3a over 2a plus 2. Okay, then from here I'm going to apply law 1. Law 1 says when multiplying power of the same base, we add. I'm gonna add the ones that are the same. So this and this have the same base, so I'm gonna add. Can you see? I'm gonna add this. This and this have the same base, so I'm gonna add. So I'm gonna have one base, 2 minus a plus 2a. Do you see it? I hope you see it. I'm adding these exponents. So I write only one base and I add the exponents. And then 2 minus a plus a. So I'm gonna write dot 2 minus a plus a over 2a plus 2, right? Then please pay attention here. I'm gonna add the like terms. So a minus a plus 2a adds like minus 1 plus 2 is gonna be plus a. It's like 2 minus 1 is gonna be 1. You still keep your base there. 3 minus a plus a, they cancel each other. It's like 1 minus 1 becomes 0. So I'm only left with 3 over 2a plus 2. So from here, can you see that these two are the same? You can just cancel them out like that right away. Or, am I right? I hope I'm right. I hope I'm not missing anything. I hope I'm not missing anything. Okay, you'll tell me if I'm missing something, but it looks fine with me. It looks fine with me. So I'm gonna subtract this 2 from this. According to law 4, it says when dividing part of the same base, we subtract. So 2 plus a minus 2. Can you get it? Can you see it? I'm subtracting this from this. So when it goes over, the signs are gonna change. But you can just cancel them, the answer is 9. But it's fine, let's do it the normal way. This and this goes out, this and this goes out. You're left with 2 0, because everything goes away. And you're left with 2 squared right there. So it's 1 times 9, which is 9. Okay. Please check it. Okay. So here, step number 4 would be what? Step number 4 would be blah, 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 blah. Also step 1, okay, law 2 here. Law 2 says when dividing part of the same base, we subtract the exponents. Sharp. Let's continue. I really hope you can hear me. So let's read this question. If ab squared is 8ab, let me write it here. If a squared plus b squared is 8ab, determine, okay, the value of a plus b squared in terms of a and b. In terms of a and b. So they want to know how much is this in terms of a and b if ab squared and b squared is minus 8ab. So what are you gonna do? Even if you don't know, like you get stuck with such questions, you can get just like pick up some few marks. Don't just leave it there. Do what you can. If I give you something like this and I say simplify, obviously what are you gonna do? You're gonna open this bracket. This means the same bracket twice. The same bracket twice. So that's why they squared, because it's the same bracket twice. Once it's like this, bracket means multiply. So I'm going to multiply this. I get what? A squared. A times b becomes plus ab. B plus a becomes ab. Plus a positive and a positive is a positive. B plus b becomes b squared. then we solve. AB plus AB becomes 2AB plus AB. And according to this, it says if I add these two, they equal to 8AB. So in the place of AB squared, if I put this one over, I didn't do anything. I just took this one and put it next to A squared. This 2 is equal to 8AB. Can you all see? Then these are like terms. So 8 plus 2 becomes how much? 10AB. So that will be your answer there. It's just I believe this question, it's working itself. The more you do it, it's working itself out. Okay, let's go on. Before load shedding. Okay, this one, look at the question. It says factorize. So remember we did those 5 rules, five laws of factorization. So which one would it be? Okay, let's not waste time. It's gonna be a cube. You can see 64 is a cube, 27 is a cube, p cubed is a cube, 1 is a cube, is a square, it's everything. So I'm gonna apply the last rule of factorization, which is 64 minus over 27. What does that rule say? It says you have a smaller bracket and a bigger bracket. I hope you still remember this. So in the first bracket, you're gonna find the cubic root of each. So this is the first term, this is the second term. We only have two terms. So FT stands for the first term, ST stands for the second term. So you're gonna find the cubic root of 64 p squared. The cubic root will be obviously come on, man. I'm only gonna put the number only the number. So I know this is a cubic, it's p. So the first term is ft is 4p, and then the cubic root of 1 over 27 will be shift square root. Remember, if I want this cubic root, I can't do it like this. This is wrong. Can you see it's giving me a different answer? You have to press shift first, press square root, and then 1 over 27, you get 1 over 3. Can you see? I really hope everyone knew how to do that. So for ft and st, first term, second term. So according to that rule, we're gonna say we write ft here, second term. So the smaller bracket, first term, second term. I mean, it's so easy. Then here, you're gonna square the first term. Whatever value of the first term is, we square it there. And here, we square the second term squared. You just put it in bracket, then you square it. Just square it. If you don't know how to square, put it on the calculator. And then ft, st. The middle term of the bigger bracket is the product of the first term and the second term. If you don't know also how to do it, just put them on a calculator. It's gonna work itself out. And then if it's a minus here, the first bracket is a minus and the other bracket is plus plus. If it's a plus, the signs alternate. So it's a plus minus plus. If it's a negative, only the first bracket is a negative. The other two is a positives. I hope you get it. Okay, so what is the first term? 4p minus 1 over 3. Is that fine? And then here, first term squared. First term is 4p. So 4p squared is how much? If I square this, 4 squared will be 16. P squared will be p squared. Do you see it? And then st squared. St is this one squared. 1 times 1 squared is 1. 3 squared is 9. Do you see it? The first term times the second term. So 4 times 1 over 3. Obviously, you can't put the variable. The variable was just going to be there. What is 4 times 1 over 3? It's 4 over 3. 1 over 3. It's 4 over 3. So here it's 4 over 3 p. Because this one has a p. Can you see? It's going to be plus plus. That's your answer there, right there. For how much? For 2 marks. Yeah. It's worth it. It is worth it. Okay, let's do this one. Hey. This one 1 2 3 4. So I'm gonna do grouping. I can just work it with it here. So I'm gonna apply grouping. Yo, can you hear me? I hope you can hear me, because otherwise this whole video is a waste. Unless you can see sign language. Okay. So here I'm gonna do grouping. So grouping says what? You introduce 2 brackets and then you introduce a plus in between. Plus in between. Do you all get it? Do you all see it? Yeah, boo, let's do it. Okay. Because I'm lazy to deal with negative values, can I just swap this 2? Can I swap this 2? Because I don't want to deal with negative numbers. So can I just write it like this? I can do that as long as you maintain the signs. I just took this one there, took this one there, but it goes with this, with the sign. This is a negative 24y. This is plus 96y squared. So why am I doing that? Because when I'm pairing them, I want to avoid dealing with negative signs. But if you want to do it, I mean, you're not gonna die because of that. So I'm gonna put this in bracket, put this in bracket, and introduce a plus in between, so that I have 24k3 minus 6ky plus. This plus is not the plus there, it's the plus that I introduced, that the one that I put. And then here in this bracket, I can just write 96y3 because of automatically we know if there's nothing here, it's a plus. So this plus falls off. But even if you write it, it's not a crime. I mean, they can't arrest you for that. Okay, once you pair this is the first step. Second step is to find a common factor. In each bracket, we find a common factor. So what is a common factor in each this bracket? 24, it's made by 6 times 4. 6 times 4. So 6 times 4. I see k, I see k, I see y, I see y. So I'm going to take out 6 as a common factor. 6ky. If I take 6ky, I'm left with 4y squared minus 1. I see a difference of 2 squares inside the bracket. I hope you all see it. Plus 96 and 24. Yeah, man. Let's see. 24 times 3. 24 times 2. Oh, man. Okay. Thirty-two times 3. So 32, 8 times 3. It's 24. 24 is made by, we need to find the factors of the 96 that relates with that one. So let's see, 8 times 6. Ayaya. All right. 8 times 12. 8 times 12, can you see? I hope I'm not confusing anyone, right? So 96 is made by 12 times 8. So 24, I can use 12 and 2. I can do that, right? Yes, I can do that. But I have to take out another common factor between these two, and then these two goes out. Yes. Men. Okay, let me take out 12 out first, né? And then I take y outside. Then I'm left with 8y squared minus what? Minus 2. I have a 2 there, 2. Then there's a common factor, there is 2. So 2, I'm going to take 24. So 24 times 3. 24 times 4. I should have used that one. 24. If I take out 24, I'm left with 3 there. I'm left with 1 there. Yeah, sorry about that. That was a short break. A very short break. Okay. Am I right now? No, I'm not right. It's a 4, it's not a 3. So here it's a 4. Can you see this bracket and this bracket are the same? So we're going to factor out the common factor. 4y squared minus 1 and 6ky minus 4y. Then I'm going to factorize in each here. It's going to be, I hope you see it, it's going to be 2y minus 1, 2y plus y. Here I'm going to take a 2 out and a y, can you see? So I'm going to have 2y, I'm going to put it out there, and 3k minus 1. Yeah, that's the answer. That is the answer, I believe. Yeah. So sorry for complicating it for you. 96 is made by 12, 24 times 4. So I can just take out 24 as a common factor. If I remove 24, this whole 24 goes out. Here I'm left with 4. Yeah, then factorize the common factor, the brackets out, group whatever is left inside the bracket, and then see if you have factorized fully. They said factorize completely. So if you leave it here, it's not completely, because of here you can see we still have common factors. Here we see a difference of 2 squares. So you need to watch out for those things. That's why the question is 4 marks. Oh, let's go on. Solve for x. We want the value of x. Okay. What are we going to do? 1 over 3, 3x3 equals to 729. So the first thing, remember, if we're given an exponential equation, the main thing we want to do is to make the bases the same so that we drop the bases and we equate the exponents. So I'm going to make this a prime base first. 729 equals shift fact 3, 6. So I have 3 exponent 6. Remember this 1 over 3, we can write it as an exponent. Remember, as a negative exponent. I hope you still remember that. So I can write 1 over 3 as 3 minus 1. 3x plus 3. I can write it like that because of that property that I showed you earlier. And then bracket means what? Bracket means multiply. So I can multiply everything with negative. So negative 3 becomes a negative 3x. Negative 1 times plus 3 becomes a negative 3. See? Once the bases are the same, we can drop the bases. I hope you still remember this principle. If I give you something like this, you make it 3 squared, and then you say therefore x is 2. X is 2 because of the bases are the same. So same thing here. Drop the bases because the bases are the same. I'm going to have 3x minus 3 equals to 3. Take this to the other side. If it's a negative, it becomes a positive 3, and then divide both sides by 3. Divide by 3. X is a negative 3. So this means if I put -3 there, I'm gonna get that one. We want to try it. Let's see. If it doesn't work, yeah, you'll see what to do. It's not my problem. It's not my problem. Okay, there you go. You see, so nothing there. So let's go on. Let's go on. Okay, solve for x and write the answer in interval notation. Wow. We usually do it in the number line. So let's see what's going to happen in interval notation. Okay. Interval notation. Okay. What is interval notation? Okay, let's try it here. So the first thing to do is to get rid of the denominator. How do we get rid of the denominator? We multiply both, everything, not both, because we have 3 sides now. We multiply everything by the denominator. So multiply by 3, multiply by 3, multiply by 3. Always. Okay, let me try this. Always when we have okay, let me charge my phone. Let me charge the phone. Always, I was saying what? Always when you have a negative, a fraction, and you want to get rid of a fraction, you need to multiply. You need to multiply by the denominator. Always when you want to get rid of that. So this one and this one cancels out. So in the middle, I have 1 over x over 3 times this multiplies together. Because they are both numerators, this multiplies together. They are both numerators also. Then I'm going to take 1 to the other. Hey, what am I doing? Take 1 to this side, take 1 this side. So I'm going to distribute this one. Remember, it's a positive. When it goes across the inequality sign, it changes sign. So it's going to be both negative on the sides because it's positive. So I'm going to have -1 and 9 minus 1. And here I have what? 13. So I have a -13. And then I have 9 minus 1 is 8. Yes. Then I'm looking for x, not for negative x. So I'm going to divide all the sides, everything by -1. So when you divide by a negative, number, the inequality sign changes direction. All the inequality signs, they change direction. So they're facing there, they're all going to face the other way. So a negative and a negative becomes a positive. Okay. 8. So that's the way to write it. But we always start with the smaller number and we go to the bigger number. So I'm going to write 8. It's bigger. 13. Can you see? But even if you write it like this, it's fine. Usually we just start with a smaller number on the side. So x is greater than 8 but less than 13. So x is less than 13, greater than whatever there. And on a number line, it's going to be something like this. So here it's not included. So it's an open circle. Here it's a closed circle or a closed dot or whatever. Anything between 8. So 8 is not included. So anything from 7 going there. Not 7, 9. 7 is this side. So 9, 10, 11, 12, 13. All these numbers are the values of x that will satisfy this inequality. And then, you say x is the element of, if it's not included, we used a curved bracket. And then if it's included, we use a square bracket. So x is anything between 8, which is not included, and 13. So this is the interval notation. Interval notation. Sometimes they can ask you to list the values, so it will be okay. So they can ask you to list the values or whatever, or interval notation or number line. So I hope you can see. I hope you can see. I hope you can see. Sorry if you didn't see. I'm sorry. I'm sorry. Okay, let's go on. Let's go on. I'm really hot now. Okay, let's do this question. Okay, so tickets for a concert are sold at 6 rand for children and 10 rand for adults. If altogether 150 children and adults attend the concert, if altogether 150 children and adults attend the concert and pay 1,100 entrance fee, determine how many children attend the concert. So your biggest or your wildest guess will be, this cannot be a finance question because it's undersolved for x. So if it's undersolved for x, it's most probably simultaneous equation. So we have to change the statement into an equation, a mathematical equation, so that we can solve it. So there is a concert at school. Children and adults are supposed to be there. So I'm going to say let x be the children. Okay, and let y be what? The adults. So they pay this amount, children, and each parent pays that amount. And then they say altogether the total number of adults and children in the concert is how much? So meaning x plus y, children and adults, are add up to make a total of 150. So that will be my first equation. And the total money paid, the total amount paid was 1,100. Each child was paying 6 rand. So I'm going to say for each child 6x, meaning 6 times x. Each child pays 6 rand plus 10y. Each adult pays 10 rands. The total amount of this is how much? 1,100. Can you all see it? Therefore, we have a simultaneous equation right there, and then we can work with it and deal with it quickly. So there are many ways of doing this. There's simultaneous equation and elimination method, but I always advise you to learn the substitute. What did I say? I don't know what I said. I always advise people to use the substitution method, because moving on from grade 11 to 12, you will really use this one most of the time. Elimination method, it might work, it might not work, but substitution method, you're guaranteed to do this up until matric. So I'm gonna do that one only. So I'm gonna say this is equation 1, this is equation 2. So I'm gonna use equation 1 to create equation 3. So I'm gonna say I just took y to the other side, make x the subject of the formula. So let this be, oh wow, I see what I did there, equation 3. Okay, I'm gonna say substitute equation 3 into equation 2. Because I used equation 1 to create equation 3, I'm gonna substitute equation 3 into the other equation, which is equation 2. So wherever I see the value of x, I'm going to write 150 minus y. So this equation is 6x. So in the place of x, this x, I'm going to write 150 minus y plus 10y equals to 1110, and then multiply in. So 6 times 150 is 900 minus 6y. That's why I got y plus 10y equals to 1100, 1100. And then take the 900 to the other side. So it's going to be 1100 minus 900. Minus and this are like terms. So minus 6 plus 10 becomes 4y equals to that. Do you all see how I got this one? This is how much? This is 200. 200 4y over 4 over 4. And then 4 goes into that. Even if you know the answer, you just press on the calculator to make sure that you avoid mistakes. So y represented what? Adults. So according to this working, there are 50 adults. In total, there are 150. So you can just see that meaning x should be 100. So, okay, I'm going to go to equation 3, which said x equals to 150 minus y. I substitute in the value of y, which is 50. I get 100. So there are 100 children and 50 adults. They are adults. So this was a simultaneous equation. So for the fact that it was under question 4, whereas they told us it's a solve for x question, so you might work around that. Okay, let's go on, people. We're gonna do question 5, and then we do question 6, because I am tired. Okay. So this one works, is fairly easy. Question 5 was 3 marks, imagine. It's a, what do you call it? Oh, it's a patterns. Now, let me just check. Come on, just give me a minute. Yeah, I'm here, people. I'm here. Sure. Yeah. So minus 3 minus that, minus 3, 1, 5, and 9. So consider the following pattern. We don't know, but usually in grade 10 we deal with linear pattern. So from 5 to 9, I'm adding 4. From 1 to 5, I'm adding 4. It means from minus 3 to that one, I'm adding 4. And then determine the general term. It's a linear pattern. How do I know it's a linear pattern? Because the first difference is constant. Can you see? I'm adding the same number all the time. So the formula for this one is that, okay, where D adds the difference, and I get it by saying T2 over T1. Let me do this one. Hello? Yebo. Sharp one, huh? Okay, well, just call me after 5 minutes. Sharp, yeah. I don't know. Okay, sorry about that, people. Okay, A is the first term. first term, which is T1. I get the first term of the sequence, the first term that you see there, the difference. Okay, so I'm gonna substitute. Let's do this one, T2 minus T1. Remember, this is my first term, this is my second term. So 1 minus 3, 1 plus 3 is 4. Can you see how we get 4 there? Then we substitute in our equation. A, it's minus 3 plus minus 1 times 4. Minus 3 plus, what am I doing here? Minus 3 plus, multiply in 4 times n, it's 4n. 4 times minus 1 is minus 4, so 4n, and then minus 3 minus 4 becomes minus 7. So that's the general term. I hope you all get it. The other question says calculate T38. T38 will be how much? T38 will be the 38th term. So in the place of n, you just write 38. This was 1 mark. So that's T38. In the place of n, you just put 38. You get your answer. Okay, let's do this question. Oh man, I hope I do it under this time, because I am tired. If I was not explaining, I should have long finished, I'm sure. And because it's not about doing the paper, it's about explaining. Okay, let's analyze this. In the given sketch, the graphs are represented. So we need to know the types of graphs. This is a topic on functions. So remember, we've got a straight line, parabola, hyperbola, exponential equation. So you need to know the shapes, the formula for each, what each variable mean, and all of that. So this one, it's a parabola. A parabola, it's something like this. It's either smiling or sad. We've got a TP, a turning point. So Q determines our turning point, which is also our y-intercept. And then this one is a straight line graph. And then it's given as mx plus c, mx plus c. C determines our y-intercept, where the graph cuts. And this, we see the exponent there, it's an exponential equation, where Q is the asymptote. Asymptote is the line the graph doesn't touch. It gets close to, but it should never touch. Okay, and they told us A and B are the intercepts, are the x-intercepts, and says the turning point of F of the parabola. Can you see F is the parabola? So this one. So here, automatically we know the values of, we know that this is 0, 0. No, what am I doing? Y is 0. We know the value of y. We don't know the value of x. Because x-intercept, y is 0. So this one here, we know that x is 0. We don't know the value there. We don't know the value there. We don't know the value there. D is the y-intercept of G. K is 1 and 4 on the point of the H, which is this one, exponential graph. Okay. So let's start. Oh, people. Okay, let's start. Calculate the length of GH if OF is 1 unit. GF, where is GF? GF is this one. GF, we want to know how much is this. If OF is minus 1, so if the point from here to there, it's minus 1. Just hold on, Ash. Hold on, I'm coming back now. Someone is knocking. People, yeah, today is a good day. That's why I'm being distracted. So look, OF is 1 unit. So from here to there it's 1 unit. So if I'm labeling the graph of x, meaning this point here is 1. That's 1 unit. Can you see? So meaning I am given the value of x. So meaning here x is 1, g is 1. Do you see it? So this means I can go ahead on the graph of the straight line g, substitute the value of x to find the value of y for g, né? And then if I'm on h of x, I can substitute in the value of 1 here. On which graph? On the graph of f to find the value of y. Can you see it? So this one is the straight line. So g of x, x plus 2, x is 1 plus 2. So 1 plus 2 is how much? 3. So this means g of x is 1 and 3. I hope you get it there. I hope you all get it. And then if I'm looking for h of h, the point h, what's happening? H, f, the graph f, so I'm going to say f of h, it's 3x squared minus 12. So in the place of x squared, I'm going to write that one, and then I'm just going to put that one in the calculator. It's minus 9. Can you all see? So this one is minus 9. So, oh, sorry. So this one, no, this one. And then this one. Can you see this one is 1 and 3? So the distance between here and there will be how much? So the value of x is the same. So it will be 0 even if we subtract. From this part here to this part is 3 units. And from that part to that part is 9 units. So I'm going to say 3 plus 9. 3 plus 9, which is 12 units. Remember, when we're dealing with distance, we don't really focus on the negative sign. We only take the positive sign. So 3 and 9 will give me 12. Okay, quickly let's move along. The coordinates of E, which is the point of intersection, they tell you something very important. F and G, they meet at point E. Can you see here? Point E, F and G. F and G. So this, we call it the point of intersection. Where these two graphs meet, it means that in this point, the value of E is the same for the two graphs. So f of x and g of x, they share a point. So point of intersection means f of x and g of x are the same. What is the graph of f? The graph of f is 3x squared minus 12. What is the graph of g? The graph of g is x plus 2. Do you see it? And then we solve for x. We want the value of x. Remember, we want point E. We want to know the coordinates of E. So take this one and this one to the other side. Minus x. I'm just putting it there. Minus 12 minus 2 equals to 0. 3x squared minus x. This is minus 14. Okay, then we factorize here. Let's factorize. 3x squared and minus 14. 3x and x. 3x squared is made by 3x and x. 14. What are the values of 14? Is 14 times 1 and 7 times 2. That will give me what? What am I looking for? I'm looking for 1 there. So let me see. If I put 7 and 2, if I'm subtracting, let's see. 7 times x is 7x. 3 times 2 is 6x. If I'm subtracting, I'm going to get 1x. Can you see? So this one works. So I'm going to say 3x, 7, x and 2 equals to 0. Remember, if the signs I'm subtracting here, okay, very low, yeah. if I'm subtracting here, I'm subtracting, and also it means that the signs in the brackets are what? Different. So if they are different, the sign in the middle will go to the bigger number. Between 7 and 2, which number is bigger? 7. So 7 will have a negative, this one will have a positive. Then I'm gonna equate each bracket to 0. Then take this one to that side. X is 7 over 3. X is minus 2. Then we have to choose between a positive value and a negative value. Look at point E. Point E. The value of x here, is it negative or positive? That's what you must ask yourself. Are we dealing with a negative number or a positive answer? You look at the position. Where is your point? Our point is in the first quadrant, and we know that here x is positive. So we are going to disregard the negative value. We're going to take the positive value. Now, I know here it's 7 over 3. Now I'm looking for the x or y value. When you're looking for the y value, you can substitute the x value in any graph, in any of the two graphs. You're going to get the same thing because they are exactly the same at that point. So you always take the easier one. I'm going to take g of x. G of x equals to x plus 2. In the place of x, I'm going to write 7 over 3 plus 2. And then you press that on a calculator. 7 over 3 plus 2 adds 13 over 3. So that's the value. Remember, g of x is the same as y. So this means the value of y is 13 over 2. That is the coordinate of E for how many marks? For 5 marks. Can you see? So you had to do some work because it's 5 marks. Quickly, I'm done. The equation of H. The equation of H, look at the equation of H here. Let's label the graph. Identify the graph of H is this one. Can you see that it has an asymptote on D? The asymptote is on D, and D is a point passing along the graph of the graph of G, and they told us that it's cutting at 2. 2 is the y-intercept. The graph is cutting here, meaning the value of D, it's 2. Or I can say D is 0 and 2. Why am I saying is that? Because of here is the y-intercept. And this happens to be the asymptote also. So here, this is the asymptote, is the line y equals to 2. Therefore, if I'm finding, can I do it here? If I'm finding ax plus q, q is the asymptote. So q is how much? Ax plus 2. Because of, it is the asymptote of what? It is the asymptote of the hyperbola, but it is the y-intercept of the straight line graph. So in this case, what am I missing? I'm missing the value of a. How do I find a? I substitute any point along the graph of h. Is there any point on the graph of h of x? Yes, it's this one, the value of k, 1 and 4. So in the place of 1 and 4, so remember, coordinate is the value of x and the value of y. So where I see h of x, I'm going to put what? 4. 4 equals to a. Where I see x, I'm going to put what? 1 plus 2. Can you see it? Take 2 to the other side, it becomes 4 minus 2 equals to a squared. 4 minus 2, not a squared, a1. 4 minus 2 is 2 and 1, a1. Therefore, we know that there's 1 there. So the same principle applies. When the bases are the same, we drop. When the bases are the same, we drop the bases, equate the exponents. Also, if the exponents are the same, we can drop the exponents and equate the bases. So therefore, the value of a is 2. Therefore, our graph is like this. The asymptote and the value of y. So that's h of x. And then, let me do this one quickly. Reflect this one in the line y-axis, in the line blah, 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 blah. Remember, reflection in the x-axis says what? When we are reflecting in the x-axis, y becomes negative. When we reflect in the y-axis, x becomes negative. So the rule for this one says this. Reflection in the x-axis, y becomes negative. So I'm reflecting f. So let me write f. Okay, it's minus 12. And then I'm reflecting it in this rule. In the x-axis. So remember, y is the same as f of x. So I'm going to change f of x. I write y. And then I'm going to make this one a negative. And then divide both sides because your y, your output must always be positive. So therefore, I've got my new rule as this one. And they said we should call it what? K. So I'm going to call this one K of x. It's reflected in the y-axis. Okay, so what happened? The signs just changed. So nothing hectic about this one. We just changed the signs. Then we're doing the last question. The last question, for which values of x is f of x greater than 0. So remember, this symbol means any number that is greater than 0, it is a positive. Any number greater than 0, it is positive. So let's go to our graph. Our graph is positive where? From here to there. Here the graph is negative. Can you see it's below 0? The graph becomes positive from B up and A there. Can you see? Because it's below, it's above this line. It's above this line. Here the graph is positive. Can you see it? So obviously we need to find the value of B and the value of A. I don't think we did it already, so I can just do it here quickly. F of x, 3x squared minus 12. Make this one 0 because of x-intercept, the value of y is 0. 12. Divide both sides, everything by 3 by 3. I'm going to get 0 equals to x squared minus 4. Difference of two squares, so x plus 2, x minus 2 equals to 0. Therefore, x is a negative 2 and x is a positive 2. I hope you can all see it. So this means this is a minus 2, this is a 2. So therefore, where is the graph positive? The graph is positive when x is greater or equals to 2, or when x is less or equals to minus 1. So I'm going to write it here. So x is greater or equals to 1, or x is greater or equals to 20. We are done, people. 1 hour and 13 seconds on the dot. So thank you. I believe this question, it summarized a lot of concepts. So if you go through this over and over and over and over and over again, we don't have a question on probability or finance, but it's not too bad. So yeah, thank you. Please like the video, share, send the link to your friends, comment, and do what you're supposed to do.